Hello, calculus fans. Let's find the curvature of the parabola y equals x squared at the point 2, 4. Seems pretty straightforward. One way we can do this is by parameterizing the curve as t, t squared. And then what we'll do is we'll find the curvature at t equals 2. So we start with r of t, and then we compute r prime. And the next thing we need is the length of r prime, which is going to be the square root of 1 plus 4t squared. So we have the unit tangent vector, so that's r prime made into a unit vector, and we get 1 over square root of 4 plus t squared, comma, 2t over square root of 1 plus 4t squared. Now we have to take a derivative of t. This is where it gets messy. And here I'm going to let you double check that everything is okay. But the expression for the derivative of t was so messy that here is the I component, and then this whole thing here is the j component. What a mess. Here it is cleaned up just a little bit. Things cancel out and we can reorganize it. And now at this point, what I'd like to do is create a common denominator for these two terms here. And we create a common denominator by taking this piece of it here and multiplying top and bottom by 1 plus 4t squared to the first power. This all cleans up pretty nicely. Looks like this. And now here's our final expression for t prime. Now let's go ahead and write down the curvature. The curvature is the length of t prime over the length of r prime. So in the top you see the length of t prime, and the bottom we've already computed the length of r prime. Now we turn towards trying to clean this up. So through this process we just have a little bit of algebra to do. And here's our final result. This is the general formula for the curvature at any value of the parameter t. And so for our final step, we'll just plug in t equals 2, and we get the curvature at that point. And we end up with 2 over 17 to the 3 halves. Okay, that's all for now.